I'm Anil Kumar. Welcome to my series on probability. Here we are taking a few questions which will get you started. Now, some of these questions are also from previous test papers of grade 10 CBSE board. Now, in all these questions, what you should assume is that we are doing random selection and the game is fair. So if we are using a dice, we'll assume it to be a fair dice. If you're using a coin, we'll assume that to be a fair coin. And a deck of cards will have similar, exactly same type of cards, but there are 52 cards and you know what that is, right? So now let's get started with some questions to understand very basic concepts, and then we'll take up 6 or 7 excellent questions which will cover a lot of concepts about probability. I'd like you to pause the video, answer the questions, and then look into my suggestions. Question number 1. Probability of drawing a red queen from a deck of cards. Probability of throwing a perfect square with dice. Probability of not getting head in 2 trials. Probability that the 3 cards picked are aces from the deck, so simultaneously picked, right? Provide an example where probability is 0. So the very first one is probability of drawing a red queen from a deck of cards. So there are 2 red queens, right? So queen of hearts and queen of diamonds, and there are in all 52 cards, correct? So that becomes the probability, which you could also write as 1 over 26. Second question. Probability of throwing a perfect square with dice. So there are 6 numbers in all in a dice, so we could always write 6 in the denominator. But what are the perfect squares? Numbers 1 and 4 are perfect squares, right? So these numbers are perfect squares. So we have only 2 of them, so 2 out of 6, which gives you the probability as 1 over 3. So I hope this term perfect square is clear. Probability of not getting head in 2 trials. So in 2 trials, what can you get? So you could get 2 heads, right? You could get head and a tail. You could get tail and a head, and you get 2 tails. So there are in all 4 combinations. And not getting a head in 2 trials means there is only one where you get 1 tail. So it is 2 tails, so it is 1 out of 4. Probability that the 3 cards picked are aces from the deck. So we'll assume they are picked in a sequence. So when you pick one, so first ace is, how many aces are there? This is a very tricky question, right? So let me mark here star for you. Okay, so this is very difficult question. So we'll get back to this question here. Let's do the last question. Provide an example where probability is 0. So you could actually provide many examples for this. One of them could be, for example, I have a spinner, right? So in this spinner, I can give different colors. For example, I get red, blue, and green, right? So probability of getting orange, for example, correct? Is 0, right? So is 0, right? Or any other color. So that is how you could get, you can give many examples. So I think that should not be very difficult. But now let's talk about probability that 3 cards picked are aces from the deck of cards. Now, so here, no replacement, right? So no replacement. We are picking 3, one after the other, right? So that is the case, correct? So initially there are 52 cards and 4 aces, so the probability of getting an ace is 4 out of 52. But if you pick an ace, only 3 are left, so you get 3 out of 51. And once you pick the second one, 2 are left, so 2 out of 50. So that gives you the probability of picking 3 aces in a row. You get an idea. So that is how you need to answer this particular question. Correct? You could simplify, right? So you could say, well, this is like 25, 52 goes in 4 13 times, and 3 will go in 51 17 times. So you get all this number, which is 1 over 13 times 17 times 25 in your answer, right? So you could use calculator to calculate this out. Even if you write like this, it is not a bad option. That is, I think, correct option. Correct. Okay. Now let's move on and get started with some questions. Question number 1. 3 different fair coins are tossed together. Find the probability of getting exactly 2 heads, at least 2 heads, at least 2 tails, at the most 2 tails. Now in these questions, we will always find that these terms are very confusing. Exactly, at least, at the most. So we'll try to understand these terms with the help of the example given to you. So we have 3 different fair coins tossed. You could get head and a tail. So if you have 3 different, you can make a tree diagram. So one option is you could make a tree diagram and then answer, correct? So equivalent to tree diagram is, I'll write down the options. So if we begin with heads, let's say we get all heads, right? So that is kind of one option. And then we could have, well, in all, when we are doing 3 coins, in all there are 8 combinations, right? So in every position, you could get head or a tail. So now we'll assume first 2 positions to be head and the last position to be tail, right? And then we'll say the second position to be tail, the third could be head, or the third could be tail, right? Now, in all these, we have considered head was the first thing. Now, we could begin with tail and then say head, head. And with tail, we could say head, tail. With tail, we could get tail, head. With tail, we get tail, tail. So these are 8 options which you get with 3 coins tossed together. Now, let's answer these questions, right? So total number in our sample space, total is 8, right? Now, how many are favorable? So whenever we talk about probability, it's the ratio of favorable to total, right? So that's what we're trying to figure out. Exactly 2 heads. So just count. Which are the combinations which have exactly 2 heads, right? So when you look through this, you'll find that there are only 2 places where we have exactly 2 heads. No, there are 3. Here also you have, correct? So be careful when you're counting, correct? So we see that there are 3 positions with exactly 2 heads. So the probability is 3 out of 8, correct? So that is how you get the first one. Now, at least 2 heads. So when we are talking about at least 2 heads, that means we could have 2 or 3. So at least 2 heads means 2 heads or 3 heads. Correct? So to this 3, we'll add the one in which we have all the 3 heads. Correct? So we have in all 4 out of 8, which is also equal to half. Now, the question here is at least 2 tails. Now, similar to what we did just now. So at least 2 tails, we look for tails which are 2 or more, right? So one combination, and then we have 2, 3, and 1, 4. So here also you get 4 out of 8, which is same as half as we did in the previous one. The last one here is add the most 2 tails. So when we say add the most 2 tails, we are trying to say we get 2 tails, right? That is 1. We get 1 tail, that is another 1. And also no tail, right? So all heads. So we have to consider all this. So when we say add the most 2 tails, you can also think about not 3 tails. Do you understand? So we are actually excluding this, and all of them are otherwise the options we are looking for. So they are favorable, right? So in this particular case, at the most 2 tails, we get the answer as 7 out of 8. Do you get the idea? So it is complement of all tails. Do you see that? So that is how we should be answering question number 1. So I hope the concept is clear. Now let's move on to question number 2. Two dice are thrown together. Find the probability of getting a prime number in each dice and getting the sum as 6 or 7. Now, a couple of ways to do this. The best, whenever you have two dice, what you could do is just make a matrix with 6 numbers on each side, correct? So when you have a matrix, it is easy. So you got one number 1, 2, 3, 4, 5, and 1, 6. And here also 1, 2, 3, 4, 5, and 1, 6. So when you have a matrix, then you could solve all these questions. So let's say one dice, you get numbers like 1, 2, 3, 4, 5, and 6. The other dice, you could get numbers like 1, 2, 3, 4, 5, or 6. Now that should help you to answer this question, correct? So first one here is, two dice are thrown together, find the probability of getting a prime number on each die. So the prime numbers which you are looking for are these, right? So this is not a prime number, I'm so sorry. Prime numbers are 2, 3, and 5. So these are your prime numbers, which are on each die. You want 2, 3, and 5. Right? In all, there are 36 combinations, right? So these are 36 in all, 6 times 6. So total is 6 times 6, which is 36. Now, you're looking for the cases where we have on both the dice prime numbers. That means 2, 3, 5 and 2, 3, 5. So if you look into it, it is how many? So let's look into this. So these are the required numbers, which you could also get by multiplication of 3 by 3, which is 9, correct? So basically, you get this as 9 over 36. You get an idea. Or we get 1/4, correct? So you can see for part A, the number, prime numbers will be, so the probability of getting prime numbers over total, right? Or we say sample space. So it is 3 by 3. There are 3 values which are prime numbers, right? So it is 3 times 3. And here we have total 6 times 6, correct? So that is how you get your answer as 1/4. So it's quick to get the answer. The next question here is getting sum of 6 or 7. So what are the places where you get sum of 6 or 7? So if you take 1 and then add 5, you get 6. So let's do 6 first, right? And then we'll do 7. So with 2, you see a pattern, right? With 2, you get 4, with 3, with 4, and with 5. So these are your 6s, correct? And then for 7s, we have with 1, it should be added 6. So these are your possible for 7, these combinations. Straight away count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 11. So for B, we get 11 over 36. That makes sense to you, right? Now, you could have many variety of questions based on this, correct? Product, sum, all this can be solved using this particular matrix. So we have learned two very important concepts to begin with. In the first example, we talked about playing with or tossing a coin, right? Tossing a coin and now the dice. So that gives you 50% of your test questions on probability. Perfect. Now let's move on to the third question. Now in the third question, I'd like you to pause the video, try to understand the question, solve, and then we'll take it up after a break. So I hope you enjoyed the wildlife. A lot of birds here, and they are very friendly to me. I've been just walking these trails for last 15 years. Now let's begin, rather continue, with the rest of the questions. Now these are application questions which are slightly tricky. Question number 3. A number x is selected at random from the numbers 1, 2, 3 and 4. Another number y is selected at random from the numbers 1, 4, 9 and 6. Find the probability that product of x and y is less than 16. B. Find the probability that product of x and y is more than 16. You can pause the video, answer the question and then look into my suggestions. So we'll follow the same strategy here. We'll draw our matrix, right? This time it's only 4 by 4, right? 4 by 4 gives us 16 options, 4 times 4, correct? So these are the 16 options, 1, 2, 3, and that's the fourth, right? So let's write down the numbers given to us. So the number x could be 1, 2, 3 or 4. The number y could be 1, 4, 9 or 16, right? So in our sample space, total numbers is, let me write, sample space has 4 times 4, which is equal to 16 numbers, correct? Now what do we want? First, find the probability that product of x and y is less than 16. So that means if I multiply these two, we should get less than 16. So of course, nothing in this row, right? So less than 16 means, let's put with 1, we could multiply all of them except 16. With 2, we could multiply these two. With 3, we could multiply 4 times 3 is 12, so that is fine. And with 4, just 1. So these are all the favorable chances, correct? How many are these? Just count. 1, 2, 3, 4, 5, 6, 7, and 1, 8. So we get 8 over 16. So the answer here is half, correct? So that is the probability. Now let's take up the next part, which is the probability that the product x and y is more than 16, right? More than 16 means everything here? No. Something could be equal to 16 also, right? So let's cross out those which will give us 16. So 4 times 4 and 1 times 16 is going to give us 16. So now we are left with 1, 2, 3, 4, 5, 6. So this answer should be 6 over 16. Perfect. Dividing by 2, we get 3 over 8 as our answer. So as you can see here, it is much faster, better and accurate to make a matrix and then answer such questions. Let's move on and take up question number 4. A bag contains white, black and red balls only. A ball is drawn at random from the bag. If the probability of getting the red ball, so let's write down. If probability of getting the red ball is 2 out of 5 and probability of getting the black ball is 3 out of 10, then find the probability of getting the white ball. So this is what we need to find. Now what is the concept? Sum of these probabilities should be 1. That is the concept. Since the bag contains only these 3 colors. Perfect. So we'll write probability for red ball plus probability for black and probability for white should be equal to 1. So we have 2 over 5 plus 3 over 10 plus probability of white should be equal to 1. So now we can write down our answer. So probability of white is equal to 1 minus 2 over 5 minus 3 over 10. So 10 being common denominator. So it is 10 minus 2 times 2, 4 minus 3. Correct? So probability for getting the white ball is what? So if you take away 7, you get 3. So it is 3 over 10. So that is how you get your first answer, right? So that is the probability of getting a white ball. right? So this is answer. Now, we have a second part to this question. That is, if the bag contains, so that is the second part, if the bag contains 30 black balls, find the total number of balls in the bag. Now, we have 30 black balls. Probability for black is 3 out of 10. Correct? So if we have X black balls, let's say X black balls, in that case, what is the probability? Right? So probability, a bag contains 30 black balls. We know this is 30, I'm sorry. So we'll say let X be total number of balls, right? Total number of balls. Okay. In that case, the probability for black has to be, we know there are 30 black balls. So 30 over X is the total number, and that should be equal to 3 over 10. Is that okay? So now we could just cross multiply and get our answer. So X is equal to 30 times 10 over 3, right? So that's what we get, and that is 100. So total number of balls are 100. So that is the answer for part 2. So we get 100 balls in the bag. Does make sense to you, right? So that is how you could answer this question. Now here is question number 5. 2 dice are thrown one after the other. Let X be the number on the first throw and B be the number on the second throw. Find the probability that A over B is greater than 1. You can actually pause the video, answer this question, and then look into my suggestion. So whenever we are doing 2 dice, as we said earlier, we'll draw the matrix. So 6, right? So 1, 2, 3, 4, 5, and 1, 6. And this side also 1, 2, 3, 4, 5, and 1, 6. So what are we looking for? We are looking for ratio of A and B. Right, so let's say first die, the numbers could be 1, 2, 3, 4, 5, and 6. The second die, the numbers could be 1, 2, 3, 4, 5, and 6. Now we are looking for ratio of A over B, right? So let's say this is A for us. Let's say this is A for us and that one is B for us. Okay, so that really means that this number should be greater. Only then we get the ratio greater than 1. Perfect. So what are the options? Favorable. So with 1, you can't get any, right? So this is 2 is greater than 1. So that works. 3 is greater than 1 and 2. 4 is greater than 1, 2, and 3. 5 is greater than these 4 numbers. And 6 is greater than these numbers. So those are favorable, right? So the favorable over total, correct? That is the probability. So what do you get? Just count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 1, 15. So it gets 15 over 6 times 6, which is 36, right? You could divide by 3 and write 5 over 12, right? So that could be written as 5 over 12 also. So I hope that helps you to understand the concept, and you'll appreciate that sketching the method which I am adopting is far better than the normal one, correct? So remember here, when we say A over B is greater than 1, it means A is greater than B, right? So we are looking for A greater than B. These are our A's, okay? Last, there's 2 more questions to go. Question number 6. A bag contains only red, blue, and orange balls. The probability of selecting red ball is 1 over 4. So let's write. Probability of selecting red ball is 1 over 4. The probability of selecting blue ball at random from the same jar is 1 over 3. Okay, so that is 1 over 3. If the jar contains 10 orange balls, so number of orange balls is 10. Find the number of balls in the jar. So we have to find the total number of balls in the jar, right? Okay, so that is the question for you. You can actually pause the video, answer the question, and then look into my suggestions. So in this, let us say that number of red balls is equal to X and number of blue balls is equal to Y. And we already know number of orange balls is equal to 10. So what is the total number of balls? So total is, that is our sample space, right? So just add them up. It is X plus Y plus 10 for you. Perfect. Now, we know the probability of each type of ball. So that will give you equations to solve. So the first one, when we say probability of red is 1 over 4, that really means X over X plus Y plus 10 is 1 over 4, correct? So from here you can cross multiply and solve. So we get X plus Y plus 10 equals to 4X. Perfect. So we could just bring this over on the other side and then say what Y is equals to. Y is equal to 3X minus 10. So we get one equation. Okay. So we'll call this as our equation number 1. Second condition for us is probability of blue ball is 1 over 3. So since probability of blue ball is equal to 1 over 3, we have Y blue balls. So Y over X plus Y plus 10 should be equal to 1 over 3. Again, cross multiply. So we get X plus Y plus 10 equals to 3Y. Correct? Now, well, we can take Y this side. So we get X plus 10 equals to 2Y. But we know Y could be replaced with X, 3X plus 10. So we'll do that substitution and then solve, right? So we'll sub Y equals to 3X minus 10, right? And then solve, correct? So what we get here is X plus 10 equals to 2 times 3X minus 10. So we can solve for X now, correct? So we have X plus 10 equals to 6X minus 20. Taking X here, we get 5X, and bringing 20 here, we get 30, and that gives you X equals to 30 over 5, which is 6, correct? Now, if X is 6, what is Y equals to? Y is equal to 3 times 6 minus 10, which is 8, correct? So we get X and Y. So we know now that X is 6, Y is 8, and we know orange is 10. So we know X plus Y plus 10. So find the total number of balls. So number of balls in the jar. So total number of balls will be, so total number of balls in our sample space will be 6 plus 8 plus 10. Correct? So that is what we get, 24. So that is our answer. Perfect. So that is how you are going to solve this question. So sometimes the probability questions could be tricky, as we have here, right? So look into its solution once again. Try to understand the concepts, and then it'd be easier for you to do such questions, right? Now here is the last question, which is on the deck of cards. Question number 7. All the red face cards are removed from the pack of cards. The remaining cards are well shuffled, and then a card is drawn at random. Find the probability of getting a face card, king, and a red card. So that should not be very difficult for you. You can pause the video, answer, right? So we have how many cards? So there are 52 cards. Now it says all red face cards have been removed. So red face cards means we are removing diamonds and also hearts. 3 of each, right? 3 of each. That means 3 plus 3, which is 6 cards have been removed. Do you see that? 6 cards have been removed. So we say minus 6. And what are we left with? So we are left with 46 cards. This is without red face cards. Now, the remaining cards are well shuffled, and then a card is drawn at random. Find the probability of getting a face card. So for A, probability of face card is how much? So for A, we are looking for face card. We have removed 6 face cards. There are 12 in all, right? So it is 12 minus 6 over. We have only 46 cards left. So it is 6 over 46, correct? You could divide by 2. So we get 3 over 23 as the answer for the very first one. Perfect. Now, for the kings, since we removed 2 kings removed, 2 remain out of 46. So remember, we are left with only 46. So 1 out of 23 is the answer. As far as the red card goes, how many red cards are you left with? Well, we removed how many? 6, and all 6 were red. Correct? So it is 26 were red cards. We removed 6 of them, and we are actually left with total of 46. So we have 20 over 46 as our answer. So it could be divided by 2 and written as 10 over 23. Perfect. So that is how you would answer this question. Now in this particular video, I have taken wide variety of questions to begin with. I'm saying probability level 1. It doesn't mean that they are very simple, but they are good to start with. Okay. And they should give you a fairly good idea of how to attempt and solve test problems in your own exam. I hope you find it interesting and useful. Share your comments with me, share my videos, and if you like and subscribe to them, that'd be great. Thanks for watching and all the best.